let's start now with the next tab will be the model tab. Okay, well, if we go back to our example which was saved, I if I click here just in the my entities window in my top left corner, I can select all the entities of inside in this case geometry, the geometry group, and if I want to make visible all of them, I can do it in the external contextual tab, or I can, well, just hide all the entities which I don't need. Okay, something like this. I have them. If I want to just select the polyline. That's why I told you that this HUD toolbar is very useful. So okay, the next tab will be the model tab. What can we find inside the model tab? So basically materials and cross sections for beam elements. Okay, we have a complete library of materials: steel, concrete, reinforcing steel, processing steel, rock and soil materials, and if we can't find any of our materials, we can define a generic one. So, well, let's start from, for instance, with steel, structural steel material. We can select different codes and standards. Okay, each standard has its material. Okay, here, as I told you before, the units are the ones that they have been defined here in the beginning, but we can change them anytime, and we can see the units change, but of course we can always change them to any units. The properties of the materials are already defined. Okay, the mechanical properties, and the ones here, if we open the three menus, we can see another properties which depend on the code. If we want to perform a code check, in this case for the Euro code number 3, we have some certain safety factors, or if some the yield strength, which depends on the thickness as well. We open the charts. We can see the different value of the and in different units, which are the yield strength of the materials, and we can by default the material is linear, but if we want to perform well, in this case for structural steel, activate a material nonlinearity, and to see its behavior against plasticity, and see if the yielding occurs at certain point of the on the analysis. We can here we can see the different values. Okay, depending on the thickness. So I told you that depending on the cola which is selected here, any of these codes, then some code properties will change. So here in my strain stress diagram, I can check my behavior, my stress strain behavior chart in the tension in the compression and tension part. Okay, but as I told you, by default materials are linear, and other values are for if we go to perform a dynamic analysis, values for damping, and if we want to perform an activation and deactivation analysis for construction or stage analysis, we can make use of the activation and deactivation time. By default, all the materials are activated since the beginning, 0 days, and deactivated well with they are never deactivated. That's why they have uh, um, a deactivation time of of uh, of this time. Okay, 36,500 days. Because every in CivilFEM you will see that every material has an age, and the age of the material is calculated by the calendar time. We'll see later, and the activation and deactivation time. We'll see in another example how to deal with different activation and deactivation times, like bridge construction, um, geotechnical structures, tunnels, retaining walls, etc. Well, for concrete material, we have the same procedure. We have different codes and standards, and different materials for each code. The mechanical properties are already defined. They can be modified as well, and we have different code properties depending on the selected code. In this case, is the Eurocode number 2. But if it's changed to another code, we will have different properties. Okay, it is only for the code and checking part. Will not change the structural analysis. Well, for the particular case of the concrete, we can activate cracking, so we can set a critical tension stress and softening modulus if we want to perform a cracking and set where where is the lower tension of the value of the critical tension stress, and if we want it depending if we want the tension softening modulus, by default it's 0, but we can set a softening if we don't want to reach to the critical tension stress in a sharp way. And crashing as well can be taken into account. Grip and shrinkage can be activated as well by different methods for the concrete case. And as well, if we want to check the nonlinear properties of concrete, we can change it to parabolical rectangular behavior and check for the concrete case. You know that we have different for this material. There are properties that they are time depending. Okay, on by default, all properties are taken from the 28 days, and in this case, we are plotting a stress strain diagram for the 28 days. but if we are using activation and deactivation analysis, you can see that we have different properties for each time, and of course we can use different time than this. The software will automatically calculate the value, the corresponding value for for the corresponding time. Okay. For the non-linear behavior concrete, we have this free model, the Bouillou-Koch-Turk plasticity model, multilinear elastic and isotropic plasticity model. Okay, so we can, in this case, work with different parameters to obtain well the correct behavior of our concrete plasticity model. But we will work with the default case, which is linear. Well, rest of the materials have the same procedure, which is the again selecting the code on a standard, and then choose the material. That's for the reinforcing steel, and for pre-stressing steel we have the same. In this case, if we want to perform a code checking of pre-stressed sections, we have this value of losses that will be needed for the losses calculations later, which are the friction coefficient, another friction factor, the anchorage slip, okay, the shrinkage strain, and the creep coefficient for calculating the aging factors and other parameters for the losses calculation for the pre-stressing tendons later. Well, with rest of materials, the same rocks and soils. We have a Casagrande classification, and well, if we want to define a generic material just by Young modulus, Poisson and density, and the thermal expansion coefficient, we can define it as well. Here we will just choose our active material, and well, the next group of this model tab is the one for the cross-section definition. How to define a cross-section? Just if it's the steel case, just select the material and select the different code on the standard, European or American, and select the different shape. Okay. Once it's defined, it will be shown here in the sections entities window, and check the different units if you want to see the units in another system. Okay, and well, if you want to change one, and maybe it's better to check it in millimeters, we can change them, and we can modify them. Here we have the different mechanical properties, and we can change if we show the section, we can choose once we perform the code checking after the structural analysis, to switch between the mechanical properties from library, from this section, or from auto calculated by the software, calculating the properties according to the plates simulation. Okay, because once we discretize our section into internal CivilFEM plates. They can be sometimes some difference in the properties. So we can always switch from by default, always taken from the library. Well, here we have a different codes. Once we select a code, we have the same our properties. We can show internal section, okay, and we will have them here. Another way to define still sections is besides from library are defining them by dimensions. Okay, I can define here some dimensions. Okay, for instance, I will switch them to millimeters. Okay, so I can here define a T section by its dimensions that can be set by the user. Okay, for instance, I can set here some distances. Okay, I can show it here. So this will be the one defined by dimensions. Okay, and another way to define still sections, if we want to define a generic section which is not included in the library or in any of these shapes, it can be done creating it by plates. So once we have where we can show it, we can add different plates in different positions, so we can create different we can set here thickness. Okay, and here we can set some plates, and following this coordinate system we can add different plates, so we can create our section, a special section which is not included in any of these ways of creating steel cross sections. Well, for the concrete case, we have the same. We have predefined shapes: rectangular, circular, T, I sections, box, pipe, or we can create a generic section just by creating geometry in our model view using our Y and Z plane, and then we can capture it, so we can use this section created by ourselves and use it as it is another typical concrete cross section. Well, if we define well, a rectangular section using a concrete material, we just set here some dimensions. Here we have it, our cross section, and it will has for if we want to reinforce this section, we have different way of reinforcing it. We can add bending and action reinforcement, that's for the code checking and design, or for to plot the interaction diagram of the section. And if we want to add reinforcement, we just click here in add. Okay, it will set different points. Well, by default are 0. Well, we have predefined if it's a rectangular section, it will be have a rebar predefinition. Okay, take into account the mechanical cover. It will set some top and bottom reinforcement, uh, take into account the mechanical cover from one side and another, and we can create reinforcement by different ways, by amount, by number of bars, or by separation. Okay, uh, we can choose another. If we choose the by number of bar, we can set a diameter, for example 16, and number of bars 3, and we will have them here. Okay, and if we want to, well, redefine our, our the position of our rebar, we can as well take here into account the mechanical cover, so we can have here our our top reinforcement in our desired location. The same for this, we can set here top reinforcement. This will be the same if you want to create it by number of bars as well, and we can set here 6, and for example in this case the same with the same diameter, and here the same. We readjust the location, take into account the mechanical cover, which are here. Just had to change the sign, and here you have them. Well, we set the number of bars and diameter. Another way is to set an amount. For example, we can set here, and the view of the reinforcement will be different. In this case, we just set the total area. Well, we can set different units that will be placed here. At the end, it will be the same, depending on the well, regardless the type of reinforcement definition. At the end, what we need is the area of the rebar. Okay, if we continue with the rest of the definition, we can define the left and right rebar group. By default are by 0, or even if we want to define more groups, we can do it just by clicking in the add button. Okay, that's for the bending and axial reinforcement. For the zero reinforcement, we can define as well, depending on the plane, the transverse Y or Z zero reinforcement. Okay, we have different ways of by amount, by area, and by diameter, and the same for the torsion, which is divided into the longitudinal and transverse reinforcement. Okay, and the same. Yes, we have a different way of to define the reinforcement, because that will be taken into account later in the shear and torsion checking or design by code. Well, if we want to define another type of reinforcement for circular concrete sections. We can set here well, the outer diameter, and in this case, if you want to set the reinforcement, in this case the geometry, instead of a straight segment, will be by amount, sorry, by circumference. We can set here a number of bars, okay, and it will be placed here, okay. In this case, the point will be describing the center, and the last point from here, this distance, the point 2 will be this one, okay. It will be the radius minus the mechanical cover, okay. If we change the mechanical cover, this will update. So another type of cross sections, if we want to use a cable, these cable sections will be for can be used for, if we want to use it for a rebar definition, but in a solid element case, where we want to define these reinforcing bars, or if we want to create tendons, of course, we can define our cables of pre-stressing materials. And if we just need a generic section, we just set a material, an area, and some inertia, and torsion constant, okay. Or if not, it will be auto calculated. So that's it. That's for this tab. We have explained the materials and the cross sections.